Hey YouTube, Anthony here with Quad Questions. Just going through the second video in my series on how to use the OsDoge on-screen display. And today I actually have a NAS 32 revision 6. This is the full board, and we're actually going to be using this with our OsDoge today and programming it to work with baseflight. So the first thing that I've done is solder this, and I actually have a video on how to do this on YouTube already. The link's here. But once you've soldered this up, then you've got your OsDoge set up here. And this one I actually pre-programmed. I soldered this jumper for 12 volts. I'm going to be using a 12 volt camera and a 12 volt transmitter, so you can see here that I've actually put the solder jumpers on. I also put the jumper on for RSSI up here. So this thing is ready to go. And so basically what we can do is just line these guys up just like this. And if we did our alignment properly, the pins should just slip right in. So here I've got a Sparrow set up here, the Sparrow racing quad. It's available at QuadQuestions.com. But you can see here that I've got an OsDoge installed. I know it's a different color than what I had in the beginning of the video, but I just wanted to show you the wiring here and the way that I do this. And you can see here, actually I like to solder my wires. So I like to bring my wires in and just solder directly to the pins that I soldered onto the Doge. And my reasoning for this is, when you have a bunch of connectors and things like that, when you get into a crash, you tend to just blow the connectors off, and these things can actually also vibrate loose and come off if they were connected with connectors. And so I'm just really against them, especially for essential components of FPV. And in goggles we trust. So what that basically means is, if you lose these connections while you're flying, you go blind and you crash, and that's just the harsh reality of it. So you can see here that I've brought in my wires from my video transmitter, and I've soldered them to my ground, power, and VTX going out to the video transmitter. And then I've got on the other side ground, power, and camera. And that comes around here and goes to this camera that I've got installed on the front of the quad, just down here. I still have connectors so I can remove the components, but they're the micro JST style, so I only use those where I have to. You can also see on here that I've soldered the power wires into the Doge, and I go negative, positive, and then I like to put a piece of shrink wrap on there, just in case I crash, to make sure that those two don't touch and short out. So I believe that it was designed for a JST connector, but like I said, soldering is best, because then you can have things solidly connected. So when you're ready, what you should do is plug this top OsDoge USB port into your computer, and you can use the same USB cable that we sell for the NAS 32, and it's available here, but it ensures that this is going to work. So plug this into your computer and then follow the steps with me here. Okay, so the first thing you want to do is pull up your Arduino software, and then you want to go to the MWOSD website, just MWOSD.com. Then you can actually get some information about it. Go to the downloads page down here, and you can download R1.5 here. I'm actually going to install R1.4.1 because that's what I've been installing, and this is a new release, and I haven't fully tested this one yet. So download 1.4.1, and then I'll head back over to my Arduino software, and then save file, open, then the file that you download from MWOSD is right here. So I'll go ahead and open up the on-screen display firmware and then look through. You've got a bunch of different files for your Arduino stuff, but you want to open this MWOSD.ino file. This will also open these others, and so all of these should be in the same folder, and so we'll just do that, and then Arduino opens it. And then what you want to look at here is there's the config H files, and so you can see all of those files, GPS, global variables, all of these things are in this sketch here, but what we're concerned with is this controller software area here. So you can see over here that I've got clean flight defined in here, and all of these others are commented out with these forward slashes. But since I've got this on a revision 6 NAS32 board, I'll be running base flight, and so I'm going to come in here and comment out define clean flight, and I will define base flight as my controller software. And then this is true for all on-screen displays that are running this firmware. You can define your hardware up here, and we're defining minimosd, and this is the one that we want for the OsDoge. But there are some other options here if you've got different hardware. And the OsDoge comes stock with MWOSD, so you probably don't even need to do this. But it's going to be defining multi-Wii, so you won't get all the features that you can get if you just define the controller software that you're using. So once I've defined that, I'll plug in the on-screen display. And you should have STM32 drivers installed already for your NAS32. The OsDoge uses the same drivers, so if you haven't installed those drivers, make sure to do that. And so now I'll just come up here and I'll upload the sketch. And mine looks a little bit different because I have it in verbose mode, so I can just see what it's writing there. But I can see that AVR dude is working on my end. If you get some get sync errors, then you should double check the port. If you come up here and look at what I've got for programmer, I've got AVR ISP. For serial port, I've got my serial port, which is the Silicon Labs USB to UART, which is that the STM32, well, the Silicon Labs drivers that you get for the STM32. And then for board, I've got Arduino Pro or Pro Mini, 5 volt, 16 megahertz with Atmega 328. So you need to make sure that all those are selected, otherwise you probably get some get sync errors. Another thing is I'm doing this on a Mac. Newer versions of Java don't work, so the Java that we have installed here is the version 6. So if you have like Java version 8 and you get issues, you might want to downgrade your Java to version 6 to make this work. So now that that's done, I can go ahead and close this out. Just quit Arduino. And then I'll go back to my MWOSD folder. And if you go into the GUI part of this folder, MWOSD GUI, or the GUI, then you can see there's all of these different applications for Linux, for Mac, Windows, 32-bit, 64-bit. So it depends on which one you, which operating system you're running on your computer. So this is a Mac, so this is the one I'll load. And the next thing that you want to do is upload a font file. So hit select on font tools, and then you can see over here it says you've got default and then large, I run default. It's a little bit smaller text. If you have a problem seeing the text, you can run large. You get this message. It says font files loaded. Say OK. And then you just need to click over here on to upload. And it might help to connect first. So I'm looking for the Silicon Labs USB to UART. There it is. So it's communicating. Once you see this populate with all green, you know that you're connected and that your flash was successful. Now I'll upload. Some boards require that you have power connected when you do this. The BROSD is one of those. So pay attention to that. If you're using an FTDI on a MWOSD board or something like that, then you can usually get away with just flashing the font file without needing to power the board. It depends on whether or not the on-screen display chip is powered when the USB is plugged in or not. So that's flashing. You can see we're getting up there. If you have a slower machine, it takes a little bit longer. This one's moving pretty fast. So while this is flashing here, I'll just kind of go through here. This is where you can set up all of your things for your on-screen display. Display voltage, you've got video voltage, display amps. You can choose your amperage setup. RSSI, if you connect the RSSI, you can display it. Reference voltage, 5-volt reference. I usually leave that off. You can display your call sign for your ham license here. You can turn this on or off by sliding this bar to green. Other settings that we like to do, see, this is the United States, go Imperial. NTSC or PAL, that depends on your video camera, so you need to check that. Some Fat Shark cameras are PAL. Most of the cameras that we sell at QuadQuestions.com are NTSC. So then you can also choose to display the throttle position if you want. When you click these to turn them on, you can see over here, this gives you an example of what it will look like on your screen, which is really nice. You can also go through flight modes, sensors. We don't have a gimbal on this quad. We will use Vario. Actually, so this will tell you how quickly you're rising. Timers on there. You can do a heads-up display for your horizon bar, your sidebars. I mean, this is completely configurable here. So this customer probably won't be using a GPS, so we'll turn it off. But all of these options can be configured when you get your on-screen display via the on-screen display menu. You technically don't even need to plug this into your computer. You can do it all with your transmitter using stick commands, and I'll show you how to do that at the end of this video. So compass is another thing. If you have an acro, turn this off, but it's on for this one because we're using a full. You can display GPS time. You can set alarms. You can do all sorts of great things. And then this also has a simulator, so you can simulate different values and see how the on-screen display responds. And so this is more for when you have this thing set up and working and you want to test it. You can hook up the USB and test and say, okay, well, what happens if I have a GPS fix? But because we're not connected and looking at a live video feed, this isn't going to work right now. So this will also let you set the modes that you want in the simulator. So that's another nice handy tool. So there's also a layout editor here, so you can set some defaults here or change the layout around to your liking. So pretty neat stuff. Once you're done with everything, just hit right, and you can see up here it writes to the controller, and we're done. Okay, so here I've got a Sparrow racing quad that we've been working on, and it's got the OsDoge installed. And I'm going to set up some basic things with this OsDoge. So I think this might be the easiest way to show you how to do this. But essentially,
welcome to Tyrannus.
What we'll do is just turn everything on here.
Engines armed. Angle mode. Normal mode. Normal. Normal. Engines disarmed.
And then I'll grab a battery. So if I throttle mid, yaw to the right, and then pitch forward, brings me into my display menu. And I've got a lens cap on here now, that's why my screen is black, but if I take my lens cap off, you can see that I have video here, but I'll keep that on just so that I can show you this a little bit more easily. But as you can see here, you've got all of your PID configs here, and the cool thing about this is you can actually scroll through and set up your quad, so you don't really even need to have a computer here. So basically this right stick navigates up and down within a page, and then if you want to change values you use the left stick. So this lets you change all your PIDs for your PID configuration. Then the next screen here shows your rates, so you've got RC rate, RC expo, roll pitch rate, yaw rate, throttle PID attenuation, throttle mid, and throttle expo. So all of these things can be adjusted in the field without a computer with this on-screen display. I'll go to the next page, and here you can adjust your main voltage. So right now we're showing 15.2 volts, so that's a nice charged battery. But it's good to take a multimeter and test it, and then you can use this adjust volts setting right up here, just like that, to adjust the main volts. So sometimes the analog to digital converter's off, so you can turn this down and change your voltage that way. So right now it's pulling the voltage from the flight controller, so that's why that didn't change that just then. And then you've also got the cells here. You can change the amount of cells that you have, and that changes where the warnings are. So as I continue on, you can see I've got RSSI. So this is another thing that is good to do. So I've got RSSI on, and you can see it's 100% right now. And I want to program this on-screen display so that it knows the RSSI. So what you do is make sure your props are off, and go ahead and select set RSSI, and then ping into it with the left stick. It's going to count down. When it gets to 10, turn your radio off. Then you can see the RSSI dropping up at the top there, and just wait for the countdown to finish. It will calculate maximum and minimum, and then set up your RSSI for you. So you can see now that that's done, when I turn the radio back on, once I clear the warnings, my RSSI jumps back up. So some of the other nice features of this are you can display amps if you have a current sensor. But that's turned off right now. Then here's your display. You can actually change what you see on your on-screen display. So your sidebars, scrolling bars, throttle, GPS coordinates, all those things can be adjusted here. And then on the next page, you've got your units. So this quad is actually going to a country that uses a metric system. So units are set to metric, but if you're in America, you can set that to imperial, and then you can change the signal. So if you have a PAL camera instead of an NTSC, you can change that here. VREF is 5 volts. You can change the voltage reference. That changes the values that you see. You can also calibrate your magnetometer here straight from the on-screen display. You can put it into MagCal mode and move your quad around and get that all calibrated up. So then you've got some other things. GPS time, you can display that, adjust it, and then you can also set your alarms here. So you've got your speed timer, amps, and the alarms they flash on the on-screen display when they get low. So, and then the final thing that you have here is your statistics. So you can see your fly time, total distance traveled, max distance, altitude, speed, milliamp hour used, and max amps. So all in all, it's a very, very cool setup. When you're done, You want to go to save and exit, and then just use the stick to enter, and then you're done. So you can see here that as I move the quad around, the data on the screen will move. So the orientation of the quad is reflected on the screen. It also tells you your compass heading and some other really nifty features. So that's just one of the really nice things about having an on-screen display. Also, you can see you've got your RSSI down here and your battery voltage, which are two critical things to monitor. And then we set these up on an on-screen display switch. So if I flip the switch, I can just have critical alarms on my screen here.
Engines armed. Timer on.
So that's just another nice feature that we've got here. So if you can turn off the on-screen display and then just have a really nice view with just the warnings, or you can
Heading hold active.
flip that switch back and see the whole thing. So thanks for watching, and please subscribe to our videos. Check out QuadQuestions.com. Please, if you have a question, post on our Q&A at QuadQuestions.com so that we can answer your questions and hopefully help other people that might have the same question. So until next time, this is Anthony. Thanks for watching.